So I'm going to go through the questions that you were given on the practice quiz so that you can check your work before taking it and seeing if you're on the right track or not. So the first several questions dealt with this figure here, and you were asked to find various intersections and unions of segments, rays, and whatnot here. So in this one here, you're asked to find the intersection between open-ended ray CD and ray DE. So when you look at this, open-ended ray CD is right here. So it's basically everything over into this area here except for this point right here. So this point really is not included. That's why there's a big circle put there, and that's why there's an open-ended here. DE is the ray that starts here and goes to here. So I'm going to show that right here. And you can still kind of see where there's both different types of blues here. Because an intersection, what's important to know about an intersection represents, the portions of these two figures that, where they're both occurring at the same time, and that's only where they're both occurring at the same time. So they're both occurring all the way through this part here. I mean, prior to point D, all I have is the dark blue line, so that wouldn't be part of the intersection. So actually what it looks like is that the ray DE itself is actually the intersection between these two, and that could definitely happen sometimes. So you can see that DE, the ray DE, not the open-ended ray DE, because D is included. D is it was a part of both of these figures here, is going to be the intersection. Same thing, that I have the intersection of ray BA and ray BF. So BA is this ray right here. BF is this ray right here. An intersection, again, is only where the two are basically overlapping each other. I mean, I have green only here, I have orange only here. The only place I have green and orange is at this point here, B. And that's why B is the intersection between these two. It's only that one point. Now, if I look at the union of these same two things, it's not much different than what I had before. Except now I have a union. Now, a union is basically the combination of all parts of one and all parts of the other. And, if there's any that belong to both, they're included as well. So basically, the union is more inclusive. It's going to include all of this. If it's in A, if it's in BA, if it's a part of BF, or if it's a part of both, any of that. So this entire thing is what the union is, and that's angle ABF. Sometimes what students do is they'll choose this angle up here incorrectly. Remember that the middle letter should be basically the vertex of the angle. So, AFB would be this angle from here to here to here, which is not even represented in the figure. So keep that in mind as you do these kind of problems, so you don't, have the right idea but indicate the wrong answer anyway. For the next problem, and I don't know why part of this is already showing, but it doesn't matter. I want to see the union of ray CD and ray ED. So CD would be the ray that starts here and moves in this direction all the way through. So this would be ray CD. Notice it also goes through E. This ray could have been called CD or CE. It doesn't matter, as long as the first point mentioned is the end point, and the second point indicates the direction it's going. So any point along this, if there was other points indicated, could be a name for this ray. Ray ED is going back this way, but it goes beyond D, so it's going to come back all the way this way. I'm looking for a union here, so basically as long as it has orange or green or both, and here in this area I have both, I would include it. And since these arrows indicate to go on forever in those directions, basically, this indicates that this entire line CE is the union of those two rays, because those two rays are heading in opposite directions along the same line. On the other hand, if I'm looking at the intersection of those same two things, again, the same principles applying here. But now, since I'm looking for the intersection, I'm only looking for where I have both the green and the orange together. And so this is the intersection of those two, and that is the segment CE. So make sure you're aware of what the intersection and union symbols mean, and make sure you know how the difference between rays and open-ended rays and segments and lines and angles and whatnot, and how they're all represented, and how they're named and things of that nature. For this next problem, you were given next 4 problems. You were given this figure to look at and ask some questions about it. And the first question you're asked is, given that this figure with those angle measurements is angle DME and angle AMB are complementary. Is that true or false? So when I look at those two angles, here's DME, here's AMB. AMB is 29 degrees, DME is 61 degrees. Well, for them to be complementary, the sum of their angle measurements has to be 90 degrees. They don't have to be next to each other. They don't have to do anything except have a total of 90 degrees for their angle. And as you look here, when I add those two things together, that is in fact the case. 61 degrees plus 29 degrees is 90 degrees. And so, yes, they are complementary. That is a true statement. For the next one, angle CME and angle CMB are supplementary. Now, supplementary means that the sum of the two angle measurements should total 180. So let's look at these two angles here. Angle CME is including these two angles together. So that means that CME is going to be the sum of these two angles. So angle CME is 97 degrees. Angle CMB, which would be this angle right here, is 54 degrees. And therefore, to be supplementary, I'm going to see if they actually total 180. So when I add those together, I get 151 degrees, which unfortunately is not 180 degrees. So they're not supplementary. So make sure you know those definitions and how to determine that. And also don't get trapped into certain situations. A lot of situations we deal with supplementary angles and complementary angles, they always have the two angles being adjacent to each other. They don't have to be adjacent to be supplementary or complementary. It's just characteristics. I mean, a lot of times, especially with straight lines and supplementary angles, if I have two angles that together form a straight line, then they're going to be supplementary because they would be considered a linear pair. So, keep in mind that they don't necessarily have to be, adjacent or right next to each other for that to happen, though. For number 8, let's say which angle is supplementary to angle AMB. So, angle AMB is this angle right here. Now, I mean, I have all these smaller angles, but, ultimately, I want to get a straight line. And so if I start here and then here for A and B, then the angle supplementary to it would kind of pick up from here and move the rest of the way to the other end of the line. So basically, the supplementary angle to A and B, which is 29 degrees, would take up the 54, 36, and 61 degree angles. And so this is the angle right here. Now there's a couple ways I can name that angle. I could call it EMB or BME, and BME is the one that we actually have listed there. So that angle is supplementary to angle AMB. I didn't have to do any addition here. I mean I could verify. I mean, from the previous part in dealing with supplementary and complementary, these do total 171 degrees, and 29 degrees would make, say back 161 degrees. No, 151 degrees. So I'm having a bad day today. 151 degrees and 29 degrees, that would total my 180 degrees, so they would be supplementary to each other. And for the last one, which of the following angles is obtuse? And you have 4 angles listed here. When I look at angle BMD, that includes 54 and 36 degrees. Those two are 90 degrees. So that's actually a right angle, so that's not going to be obtuse. When I look at angle AMC, that's these two angles combined, because here's AMC, so 29, 54 degrees. That totals 83 degrees. Although getting pretty close to being a right angle, it's still under 90 degrees, and if it's under 90 degrees, it's actually an acute angle. So that's not obtuse either. Angle CME, when I look at that, I mean, CME is this angle right here, which takes up 36 to 61 degrees. I add those together, I do get 97 degrees. And it's slightly, it's a little bit over 90 degrees, but that's all I need, a little bit, to be obtuse. So that looks like an obtuse angle. And just to be sure, DME which is pretty straightforward. It's only the one angle right here at 61 degrees. That's definitely acute. So here's our results. So the only obtuse angle we have here is angle CME. Now you had a very similar figure here. It's slightly different lettering and things like that. Where you're given that this setup and you're asked to find the measurements of angles MXN and NXO. Well, one of the first things you have to kind of notice is that, usually when we look at supplementary angles, we just say two angles are supplementary. We don't usually say 3, 4, 5 together are supplementary. And that's because usually, I could probably take, anything more than two angles, and if they're adjacent to each other, and I say, okay, well, if I put these two together to make one angle, these three together to make another angle, then these two angles would be supplementary, whatever the case may be. So I could say, like, for instance, this angle here and this angle here would be supplementary. But that means that, because I'm starting at L, if I rotate all the way through here, end up back on here, it's the same line, that L was on. So this is a 180 degree rotation here. So these four measurements should total 180 degrees. And with that in mind, I'm going to set up an equation based off of that. 30 plus 4x plus 9 plus 7x plus 31 equals 180. I had the degree markers on it, but we can kind of leave those off for the time being if we want to as well. So, and I'm going to. Since everything is addition here, I really don't need the parentheses. Now I'm going to combine some like terms. 4x and 7x is 11x. 30 plus 9 plus 31 is 70. So 11x plus 70 equals 180. I would subtract 70 from both sides to get 110. And divide both sides by 11 to get that x equals 10. Now, x equals 10, although is something I need to find here, it's not in any way the answer. Sometimes students will put this in for an answer somewhere because they're used to their algebra days and algebra work where they get x equaling a number. I think that's it, I'm done. But x does not represent any of the angle measurements. 7x and 4x plus 9 does. So I'm going to use this to figure out what these two are. So in the case of angle MXN, that's 4x plus 9 degrees. I'm going to replace the x with a 10. 4 times 10 plus 9 is 49 degrees, so this is 49 degrees. And in very similar nature, angle NXO, its measurement is 7x. I'm going to replace the x with a 10. 7 times 10 is 70 degrees, so this is 70 degrees. For this here, you're given that you have two lines intersected by a transversal, two parallel lines intersected by a transversal. You can see that these are the two parallel lines. A transversal would be intersecting them. With that in mind, I want you to figure out the measurement of all angles 1 through 7, given that this angle down here is 47 degrees. Well, when I have two parallel lines intersected by a transversal, there are certain relationships that occur as a result of that. So, and also, when I have an intersection of two lines, there's certain relationships that I can kind of expect. So how I approach this problem might be different than how you may have approached it, but as long as you get the same answers, that's all that's important. But as I go through this, I'm going to give reasons why I make the decisions I do. And that's something you should be doing as well, is making sure that whatever conclusions you're making, you're basing it off of a known fact. So for instance, I have this 47 degree angle, which I know is congruent to angle 5 because they're vertical angles, which means angle 5 should be 47 degrees. Whether I look at angle 6 and 5 or angle 6 and the given 47 degree angle, they're adjacent and forming a linear pair. So I know that these two angles here, angle 6 and the 47 degree angle, or angle 6 and angle 5, which is also 47 degrees, are supplementary. So they should total 180, and for them to total 180, the measure of angle 6 has to be 133 degrees. And once I know what angle 6 is, angle 7 is easy because angle 7 is a vertical angle with angle 6, and therefore it should be congruent and therefore have 133 degree measure itself. So I took care of all the angles that are at this intersection with the 47 degree angle. Let's look at these angles over here, and that's where the parallel line information is going to come in. When I look at angle 1 and angle 1 over here, I know it's congruent to angle 5 and the 47 degree angle. And there's different reasons why I could say that. I could say because angle 1 is a corresponding angle with angle 5. I could also say it's an alternate exterior angle with the 47-degree angle. Whichever the case may be, it makes them congruent and makes the measure of angle 1 equal 47 degrees. Now at this point, I could say, well, angle 3 is 47 degrees because it's a vertical angle. Angle 2 would be supplementary. Same with angle 4. And they would total 130 degrees using some of the same logic I used down in this intersection. And so those are the measurements of the 7 angles you were asked to find. And it's based off of knowing what vertical angles are, what a linear pair is, and being supplementary, and as well as, also knowing your corresponding angles, alternate exterior angles, alternate interior angles, that sort of thing. So for this next one, we're given this figure here, and looks like part of one of my writings got shown up here. I don't know why. I'm given that these 3 lines are intersecting each other. I know that this angle out here is 126 degrees. I know this angle out here is 56 degrees. I'm being asked to find angle X. Now again, there's different ways you could possibly approach this. There are certain facts you may have to use. You definitely have to use that I'm using. But there's other ways you could approach certain parts of this problem. So it depends on what rules you remember and know along the way. But for me to find angle X, I'm going to have to find some other angles first. And I'm going to kind of like, I notice that I have a triangle here in the middle, right here. So let's see if I can find out any information about that triangle, because angle X is an exterior angle of that triangle. So this angle down here is a vertical angle with a 51-degree angle. So this angle down here should be 51 degrees. This angle over in here, this part of the triangle, is a linear pair with this angle here. So these should total 180 degrees, which makes this angle here 54 degrees. Now that I know, now at this point, there's different ways you can approach this, because there is a rule that says that, an exterior angle of a triangle is equal to the sum of the, the alternate interior angle, or the non-adjacent interior angles. But, that's a rule that isn't really emphasized a whole heck of a lot in this course. I think it was mentioned, but I don't think it was like, a major point of emphasis. And but if you don't know that rule, you can still realize, well, the 3 angles of a triangle should total 180. And if I call this angle, say, y, then y plus 51 plus 54 should be 180 degrees, which means that y should be 75 degrees. So knowing that y is now 75 degrees and replacing that with that fact, and seeing that x is an angle that is supplementary with 75 degrees, I know that the measurement of angle x should be plus 75 should be 180, which makes x 105 degrees. Or as I said before, if you happen to remember that, that rule, that this exterior angle should be the sum of these 2 remote interior angles, 54 and 51 is 105, so you can see that that does work. Question number 13, which, I kind of clicked early and started moving on before I stopped the other one. You're just asked a simple question: what is the sum of the measures of the interior angles of a 13-sided polygon? Well, to answer that question, you had a rule that the sum of those interior angles should be n minus 2 times 180 degrees, where n is the number of sides in that polygon. That would also be the number of angles as well. And since I do have a 13-sided polygon, for this instance here, n would be 13, which means I would have 11 times 180 degrees, which would make this 1,980 degrees. So the sum of those measures would be 1,980 degrees. For question 14, you're given this figure here, which shows similar quadrilaterals A, B, C, D, and A prime, B prime, C prime, and D prime. And you're given all these side measurements, except there's 3 that are missing. You have 2 of them on the smaller quadrilateral, and you have 1 on the bigger quadrilateral. Once I know that they're similar, I do know that they should have proportional side measurements. And therefore, what I want to do is I want to figure out what that proportion should be, whether I do bigger to smaller or smaller to bigger. I do bigger to smaller on this. I got to find 2 corresponding sides that I actually do know the measurements on both figures. And I do happen to have that for these 2, AB and A prime, B prime. In the other pairing, I have 1, but I don't have the other. So AD and AD prime, I don't know. I don't know what this one is. CD and CD prime, I know what CD prime is, I don't know what C was. So the only one that I could possibly find out what this we would initially call a scale factor is this here. And 35 over 20 does simplify to 7 over 4. This ratio should stay put, should be the same for all these other sides too. If I go from the bigger one to the smaller one, so BC over B prime C prime, CD over C prime D prime, and AD over A prime D prime should have this same 7 to 4 ratio. And that's what I'm going to use to help me out with this. So when I look for X, X is A prime D prime. So I'm going to be using this ratio here, and know that should equal 7/4. So 28 over X should equal 7 over 4. I do some cross multiplying. I get that 7x equals 112, which means x equals 16. So x would equal 16. For y is b prime c prime. So I'm using this ratio here, bc over b prime c prime, but that should also equal 7/4. And since I don't know what b prime c prime is, but I do know what bc is, I'm going to have 7 over 4 equals 24.5 over y, or the other way around. I do my cross multiplication, I get that 7y equals 98, which means that y equals 14. On the last one, same setup. I mean, I'm looking for CD. CD is involved in this one up here. So when I set up the ratio, z over 4 should equal 7 over 4, which this one's pretty easy. I don't even have to cross multiply. Like 1 over 4 equals 7 over 4. Well, z has to be 7. So that one's pretty straightforward. Now in this one here, you're given a parallelogram and you're asked to find the perimeter and the area. Now the perimeter is just adding up the 4 sides of a parallelogram. I can see that this side here is 5 inches. This one here, it's split up into a 17-inch part and a 3-inch part, but together that is 20 inches. And so, you know, and these opposite sides, this opposite side here should also be 20 inches, and this opposite side should also be 5. So basically the perimeter is going to be 20 plus 5 plus 20 plus 5, or 50. And since it is a perimeter, it's still dealing with a total distance. It should still be in inches, so there shouldn't be any inches squared. I mean, the 50 alone should have told you which answer it was. Sometimes students do put down the wrong units. Be careful about that, because some of the questions on the quiz, they do ask you to identify the correct units as well, and you'll get dinged for a point on that, or part of a point, if you don't have that part right. Now, as far as the area of a parallelogram goes, for me to do the area of a parallelogram, I need to know the base and the height. So now the base could be any side of the parallelogram, so that part doesn't really matter. The height has to be perpendicular to that base. So I mean, if the 5-inch side was a base, I'd have to have you know, the length of the segment that would be perpendicular to it, like this segment here. You know, I'm given this segment down here is drawn perpendicular to this here, so it looks like we're going to use 20 inches as the base. I had to figure out what the height actually is, so I'm going to use some information here. I'm going to let that be the height. This is, of course, is the base, and I know because this is the opposite side of this is 5 inches. I'm going to focus my attention on this, because this triangle here is a right triangle. And if I know 2 sides of a right triangle, because you have another angle, right angle here, this would be the hypotenuse, this would be a leg, h would be the other leg. So my approach to this is going to be the fact that, well, since I know that it's base times height for the area of this parallelogram, it's going to be 20 times h, where h is the height. I just don't know what the height is yet. But I can figure out the height by taking this right triangle and realizing, okay, this is the hypotenuse, this is the leg, so h squared plus 3 squared should equal 5 squared. That's 9, that's 25, so h squared should be 25 minus 9, which means h squared is 16. H would be 4. So a is when it says 20 times h, it should now be 20 times 4, which is 80. And so it is 80, and units should be in square inches. Area is always in square units. Volume, and we'll eventually talk about that in the next problem or so, is cubic units. So make sure you have those correctly. But for this one here, it is 80 square inches. For this figure here, you're asked to find the area of the shaded region. That means this V-shaped region right here. Now, there's a lot of things going on in this particular problem. I have these two triangles, this bigger triangle here and this smaller triangle here. And I want to be aware of those because the area of the shaded region is going to be the area of the big triangle minus the area of the little triangle. Now, for the big triangle, it's pretty nice. I mean, this is kind of being shown. It's perpendicular to this here. So if I treat this as the base of the bigger triangle, the 10, 30, and 10, this base is 50 centimeters. The height is 31.2, and the area is 1/2 the base times the height for a triangle. And so 1/2 50 times 31.2 would give me the area of the big triangle. I want to be able to subtract away the area of the little triangle, so I got to be able to find that. I mean, I know what its base is. Its base is 30 centimeters. I'm not really given its height. But I do see that, from evidence here, when I look at this side compared to this side, because I mean they have an overlap, but 30 over 50, and I do 24 over 40, which are these with the ratio of these two sides, they both equal 3/5. And since each side of one triangle is proportional to each side of the other triangle, that means that these are similar triangles. If they're similar triangles, they're going to have proportional heights as well. Therefore, the height of the smaller triangle over the height of the bigger triangle should also equal 3/5. And so, since I know what the height of the bigger one is, it's 31.2, I can set up a ratio here that 3/5 would equal the height of the smaller triangle over 31.2. Do my cross multiplication, I get 5h equals 93.6, which means that dividing both sides by 5, the height of the smaller triangle was 18.72 centimeters. And now with that, I can fill in the information for the area of the little triangles. I now know its height, I know its base, so it's 1/2 30 times 18.72. When I carry through these things, I'm going to have 780 for this one, 280.8 for this one. When I subtract them, I get 499.2. And it's still an area, so it has to be in square centimeters. So that goes along with this answer here. Your answers for these might be in a different order because the quiz is set up to have them appear in different places, so it's not always the same thing, or it doesn't always end up being A or B or something like that. So keep that in mind as well. I haven't listed here the way they show up for me whenever I copied a screenshot of it. So, and the last problem you were given, and please keep in mind, even though I focus on the area of triangles and what was previous to that, make sure you know how to do the area of all the figures that we talked about. And just like this one here, I'm dealing with the volume, and I'm looking for the volume of the shaded region, or I look at this as a can of 3 tennis balls. I'm looking for basically the volume of empty space in that can. This one I'm going to deal with obviously with a cylinder and spheres, but you must also be aware of how to do the volumes of other figures as well. So just don't take this review as me just going over these. These are the only volumes you have to be aware of. Make sure you know how to do all the other volumes too. I'm just going to give you some situations similar to those you're going to encounter on the quiz so you can handle them. But as I mentioned here, looking at this situation here, for the area of the shaded region, this brownish region, again, I said you could be kind of considered like the empty space inside of this cylindrical can when I have these 3 balls in there. I'm going to figure that out by doing the volume of the cylinder minus the volume of the 3 spheres. So I'm going to use those formulas along the way, and I also have to be able to find certain structures of that. So the volume of a cylinder is pi times r squared times h, where r is the radius of the cylinder, h is the height of the cylinder. The volume of a sphere is 4/3 pi r cubed. And I'm going to have 3 of them, so I'm going to multiply that by 3, because I can see 3 different spheres in here. And r represents the radius of the sphere. Now, as you can see here, this unit down here is the diameter of the can. If it's the diameter of the can, that means that the radius of the can or the cylinder is 3 centimeters. This is being given as the diameter of the sphere, which means that the radius of the sphere is half that, or 2.85. And of course, this is given as the height of the cylinder. In many different cases, you may have to deal with, especially with volume, you have the height of the prism, the pyramid, the cone, the cylinder, whatever the case may be. And then you may have the height of a face, or the base or something like that. Be aware of that. Make sure you're differentiating between the two and don't get them confused with each other. They are different structures. They are different things. They usually are not going to be the same thing. Just don't get them mixed up because you'll put numbers in the wrong places and end up doing miscalculations as a result. That's what I mean. Here I'm using different colors to differentiate. I mean, here I have the height, which there's only one height given here, but I do have two radii I have to be aware of. The green radius right here is again for the cylinder. The red radius is for the spherical balls that are inside of it. So when I do my substitutions, you see the 3 goes here, the 17.4 goes here, the 2.85 goes here. And when I work these out, now sometimes you might be asked to leave them in terms of pi, and so I always start that off because it's usually more exact. And I carry through I have 156.6 pi minus 92.5965 pi, which is 64.0035 pi in cubic centimeters. And other times they're not going to ask you to do that. So at this point, you would multiply 64.0035 times pi. Most calculators, scientific calculators, do have a pi button. If not, you could use 3.14 to get an approximate amount. And you get about 201.1 cubic centimeters. And that is the last question you were given on the practice quiz. If you have any additional questions with these, please make sure to get in touch with me. Until next time, have a good day.